Video today, we are going to be talking about the second part of stoichiometry. I am very sure that you have already watched the previous video where we consider different ways of interpreting chemical equations. So today we are going to consider how to do calculations on the stoichiometry. We define stoichiometry initially as the calculation of the quantities of reactants and products involved in chemical reactions. For example, let us see what stoichiometry is all about. Let's consider the reaction between calcium carbonate and hydrochloric acid to produce, we are having calcium chloride plus we have water plus we have CO2. Now, when this equation is balanced, we are going to have 2 as the coefficient behind hydrochloric acid. From this balanced equation, how do we express stoichiometry? Now, stoichiometry, as the calculation of quantities of reactants and products, it connects 2 reactants. Always note that stoichiometry connects 2 things. It could either be 2 reactants, or it could be 2 products, or it could be a reactant alongside a product. For example, a stoichiometry question can connect calcium carbonate with hydrochloric acid. Another form of the stoichiometry can connect hydrochloric acid and calcium chloride. Another form of the question can also connect calcium chloride and water. Another form might connect calcium carbonate and carbon 4 oxide. So it's very important we understand that stoichiometry connects 2 things in a chemical equation. They could either be reactants, or they could be products, or they could be a mix of both of them. Let us now consider different forms in which stoichiometry problems can appear. Stoichiometry problems could appear in 4 different forms. What are these forms? We are going to divide these forms into what we call problem types. Let's consider problem type 1. For problem type 1, we have that the given quantity is in moles and the unknown quantity is also in moles. Let's consider one example. How many moles of ammonia can be produced from 7.5 moles of hydrogen gas, as shown on the board? Let us solve that problem. From the balanced equation, we have that nitrogen combines with 3 moles of hydrogen to give us 2 moles of ammonia. Now let's consider what the given quantity is and what the unknown quantity is. Now the question is asking, how many moles of ammonia can be produced from 7.5 moles of what? Hydrogen. What does that imply? That implies that the given quantity here is hydrogen and is given as 7.5 mole. And the unknown quantity is ammonia. So we're looking for the number of moles of ammonia. What do we do in this reaction? Now, the structure of the question tells you the interpretation that you are going to use. Are you going to use the molar interpretation or are you going to use the mass interpretation? So for this problem, you're going to use the molar interpretation because the question is being asked in moles. So this particular question here relates hydrogen gas with ammonia. So I'm going to put an asterisk on hydrogen gas, another one on ammonia. So we are only going to be concerned about hydrogen gas and ammonia. Using molar interpretations, we have that from the balanced equation, we have that 3 moles of hydrogen will always produce 2 moles of ammonia. So going back to the question is asking what amount of ammonia can be produced from 7.5 moles of hydrogen. So I'm going to say 7.5 moles of hydrogen will produce how many moles of ammonia? That's what we are looking for. So I'm going to cross multiply. So I'm going to have that 7.5 multiplied by 2 divided by 3. That is my cross multiplication. So I'm going to have 7.5 multiplied by 2 divided by 3. So whatever answer you get from here is in moles of what? Ammonia. Now doing this, 7.5 times 2 is 15. 15 divided by 3 gives us 5. So the answer here is 5.0 mole of ammonia. Final answer. So this is problem type number 1. The given quantity is in moles and the unknown quantity is also in moles. Let's go to problem type number 2. For problem type number 2, like we can see, the given quantity is in moles and the unknown quantity is in grams. Let's consider an example like the one on the board. The example says, how many grams of water can be produced from 2.75 moles of oxygen gas according to the equation? Let me repeat. How many grams of water can be produced from 2.75 moles of oxygen gas according to the equation? Now, this is how to solve this problem. Now, the equation for the reaction given is we have 2 moles of hydrogen gas combines with oxygen gas, 1 mole, to give us what? To give us 2 moles of water. That's 2 moles of tea. From the given equation here, we have that the given quantity here is 2.75 moles of oxygen. So that's the given quantity. We have 2.75 moles of oxygen, and the unknown quantity is water, mass of water. We can say grams of water. So that is the unknown quantity here. So what do we do first? We can use the molar interpretation for our calculation first of all, after which you can now convert to mass. Let's start by saying that from the balanced equation, the stoichiometry connects oxygen with water. So from the balanced equation, I have that 1 mole of oxygen gas will always produce 2 moles of water. So therefore, 2.75 moles of oxygen will produce, I don't know. So I'm going to cross multiply 2.75 times 2 divided by 1. So I'm going to have 2.75 times 2 divided by 1. So whatever I have here is moles of water. So if I do that calculation, I'm going to have 2.75 times 2. It's going to give me 5.5. So I have 5.50 mole of water. This could have been my answer if the question were to be asked how many moles of water. But what's asked here is how many grams. That is the mass of water. So what I'm going to do here is that I'm going to convert the moles of water to mass of water. So this is how to do it. is how to do it. Now, number of moles of water is equal to mass of water over the molar mass of water. So what exactly are we looking for here? We are looking for the mass of water. We already know the number of moles of water. We just got it. We know the molar mass of water to be 18 grams per mole. So we're going to cross multiply to find the mass of water. So therefore, the mass of water is going to be equal to, I'm going to cross multiply. So the mass of water is going to be equal to the molar mass of water, which is 18 grams per mole, multiplied by number of moles of water here is 5.50 mole. So water. So mole cancels what? Mole. Our final answer is in grams. And what will this give us? This will give us 18 times 5.5. 18 multiplied by 5.5. So I'm having 99 grams of water. 99 grams of water. Final answer. So this is the mass of water that can be produced from 2.75 moles of oxygen. For problem type number 3, we're going to be considering the given quantity is going to be in grams and the known quantity is going to be in moles. For problem type number 3, we have the given quantity in grams and the known quantity is in moles. For example, let's look at the example on the board. It says aluminum oxide decomposes to aluminum and oxygen gas as shown. If 27.50 grams of aluminum oxide decomposes, how many moles of oxygen gas can be produced? Now let us solve this problem. According to the given equation, we have that Al2O3 decomposes to give us Al plus O2. So balancing this equation, we're going to have that 2 moles of that will give us 3 moles of oxygen and 4 moles of aluminum. So that's the balanced equation. So from the balanced equation here, what exactly are we looking for? Remember that the given quantity here is 27.5 grams of Al2O3. We have 27.5 grams of what? Al2O3. And the unknown quantity here is moles of oxygen. We have moles of what? Oxygen. That's the unknown quantity here. So this particular stoichiometry connects aluminum oxide with oxygen. So therefore, I'm going to put an asterisk on aluminum oxide, and an asterisk on what? Oxygen. So what do we do? How do we solve this problem here? We can solve this problem using the mass interpretation, after which you can now convert to what? Number of moles. Let's try it out. From the balanced equation, we have that aluminum is equal to 27, oxygen is equal to 16, and that's basically all. So that's all we need to know there. So what is the molecular weight of aluminum oxide? That's going to be 27 times 2, that's the bracket there, plus oxygen is 16, 16 times 3. So you put a big bracket here, but outside you have 2. So the 2 multiplies whatever you have there, and it's going to be in grams. So that's going to be in grams. Grams of what? Grams of Al2O3. So let's work that out and get the answer. Okay, we can still work this out too. Okay, this one is not going to be difficult because this is just barely 16 times 2, which is 32 multiplied by 3, that's 96. That's not an issue. So let's work this one out. So this one is going to give us 54, that's 27 times 2, 54. 54 plus, that's going to be 48. Okay. So that's 204. So we have 204 grams of Al2O3. All right, so from the balanced equation, we have that 204 grams of Al2O3 we produce 96. That is 16 times 2, 32, multiplied by 3. That's 96 grams of oxygen. That's from the balanced equation. So now 27.5, that's the given quantity now of aluminum oxide to produce, I don't know. So to find what you have on this side, I'm going to multiply 27.5 by 96 and I'm going to divide by 204. So I have 27.5 times 96 all over 204. Whatever I get here is what? Grams of what? Oxygen. Let's work it out. So I'm going to have my answer to be 27.5 times 96. Okay. I'm dividing that by 204. That's giving me 12.94. So I have 12.94 grams of oxygen. Now, this is not my final answer because the question says how many moles of what? Oxygen. So I'm going to convert from grams here to moles of oxygen. Remember that number of moles is equal to mass over molar mass. So for me to find the number of moles of oxygen here is going to be equal to the mass of oxygen over what? The molar mass of oxygen. So what's the mass of oxygen given here? We got it as 12.94 grams. And I'm dividing by the molar mass of oxygen, which is equal to 16 times 2, which is equal to 32 grams per mole. All right. So let's work that out. And that's going to give us 12.94 divided by 32. So that is 0.40. So we have 0.40 mole of oxygen. Final answer. So let's now go over to problem type number 4. Now, for problem type number 4, we can, as you can see on the screen, it talks about given quantity in grams and the unknown quantity also in grams. Let's consider the very first. What mass of nitrogen is required to produce 170 grams of ammonia in the Haber process? What mass of nitrogen is required to produce 170 grams of ammonia in the Haber process? So looking at that problem type, from the balance equation, we have that nitrogen gas combines with 3 moles of hydrogen gas to produce ammonia, 2 moles there. All right, so now that stoichiometry, or what the stoichiometry we're about to consider, what does it connect? Now this stoichiometry here, it connects nitrogen with ammonia. It connects nitrogen with ammonia. So let's do the mass interpretation of this reaction because we're going to be using the mass interpretation here. So from the equation here, we have that 28 grams of nitrogen, because nitrogen is equal to 14. 14 times 2 is equal to 28. So 28 grams of nitrogen is going to produce what? Ammonia here is 17 times 2, which is 34 grams of ammonia. That's what we have from the balanced chemical equation. Now we are looking for how many grams of nitrogen will be required to produce 170 grams of ammonia? So therefore, how many grams of nitrogen will be required to produce 170 grams of ammonia? So what do? We're going to cross multiply. So I'm going to be multiplying 170 by 28 and dividing by 34. So I have that 170 times 28 divided by 34. Whatever answer I get here is what is in grams of nitrogen. So what's it going to be? So I'm going to be using my calculator, and I have that 170 multiplied by 28, okay, divided by 34 gives me 140. That gives me 140. So I have 140 grams of nitrogen. So this is how to solve problems on stoichiometry. Now the following exercises on the board are just for you. Look through these problems, try to solve these problems using any of the problem types we have explained in our class today. In our next video, we're going to be talking about stoichiometry part 3. We're going to be considering limiting reagent problems, theoretical yields, actual yields. So I'm going to see you in my next video where we'll be talking about limiting reagents, actual yields, and theoretical yields. So feel free to like this video, subscribe to my channel, share this video with your friends who might be having challenges in chemistry. See you in our next video.